This video was sponsored by Let's Get Rusty. Unlike Windows, where you run an installer for virtually everything, most macOS apps are installed by dragging an icon into a folder, and apparently, this drives some people crazy. Of course, most things on X are engagement farming, but I still think it would be interesting to make a video about what is actually happening when installing apps in macOS, and also explain how this works on other platforms. Hi friends, my name is George, and this is CoreDumped. To figure out what is going on in macOS, let's open a terminal and move into the Applications directory. If we list the contents of this folder, we can see a bunch of things that appear to be files. Now, if we open Finder, macOS File Explorer, and go to the same directory, we should see the same things, right? I know what some of you are thinking. Duh. You are doing exactly the same thing, just through a different kind of user interface. Of course you are going to see the same thing. Well, not exactly. Let's pick one item, say Firefox. In Finder, if we double-click Firefox, the application launches. So at first glance, it looks like all these things are just executable files. So technically, to do the same thing from the terminal, all we should have to do is tell the shell to execute the file. But if we try to do that, boom, we get an error. But why? At first, you might think the answer is right there. The file does not have permission to execute. But if we check the permissions, we can see that it does have execute permissions. So what is going on? Well, the answer is actually right in front of our eyes. See this first letter? That tells us the file type, and D stands for directory. If we take a closer look at the contents of the applications folder, we can see that all of these are actually directories, what many people would simply call folders. In fact, if we run the tree command, we can see the contents inside them. And if we run the change directory command on one of them, you can see that it actually works. So Finder is kind of lying to us. All these things we see in the graphical user interface are not executable files. They are actually folders. Things got weird very quickly, didn't they? Don't worry, an intuitive explanation is coming. But before that, if you follow this channel, I'm pretty sure you love low-level systems, and that's exactly why I'm excited to say that this video is sponsored by Let's Get Rusty. Big companies are betting big on Rust for building critical systems. Google, Microsoft, even the Linux kernel itself are now integrating Rust into their core systems. That's not hype, that's happening. And if you're thinking about leveling up your Rust skills, whether for personal growth or to land a job working on real systems, Let's Get Rusty is the go-to place for Rust training. Created by a fellow YouTuber and one of the most beloved names in the Rust online community, Let's Get Rusty has helped thousands of developers, myself included by the way, master the language and break into systems programming. They're running a new cohort very soon, and since spots are limited, now's a great time to check it out. Visit letsgetrusty.com/startwithgeorge, or just click the link in the pinned comment below. Many people think the .app extension in macOS is equivalent to the .exe extension in Windows, but as we just saw, that is not true. In Unix-like systems, launching a program usually involves two important system calls: fork, which creates a new child process by cloning the parent, and then the exec-v system call, which replaces that child process with a new executable program. The reason the app does not launch from the terminal is that the .app path does not point to an executable file. It points to a directory. When we type something like this, the shell eventually asks the kernel to execute that path, roughly like this. But the kernel cannot execute that path as a program, because it is not an executable file. It is a directory. Now, directories can have execute permission, but for directories, that permission means something different than it does for regular files. For regular files, execute permission means this file can be run as a program. But for directories, execute permission means you are allowed to enter this directory and access things inside it. So the error message is not really saying Firefox is blocked because you lack admin rights. It is more like this path is not executable in the way you requested. We are telling the kernel, run the thing located at firefox.app, but the thing located there is a folder, not the actual binary. So why does the app launch in Finder? Well, when we write code and compile it, an executable file is created. That executable file is what we usually call a program. For terminal-based applications, that file is often all we need, because a terminal environment is mostly text-based. But in a graphical user interface, that same executable file would look something like this. Technically, we could put the executable files of all our programs in the same directory, but they would all look basically the same. The only way to identify each program would be by its file name. And that goes against the entire philosophy of graphical user interfaces, where applications are supposed to feel like distinct, recognizable objects. This is where application bundles come in. For desktop applications, we usually do not ship only a single executable file. At the very least, an icon package needs to be shipped alongside the executable so the operating system can display an icon that makes the application feel unique. And real-world applications usually need dozens of additional files, not just an executable and an icon, dynamic libraries, default configuration files, plugins, frameworks, localizations, assets, and many other resources the app might need. All of these things are part of the application bundle. The problem is that if we simply put the executable, icons, libraries, and configuration files next to each other, they would all appear individually in the File Explorer. And of course, this raises an important question. How does the operating system know which specific icon to show for each specific application? Well, it turns out that this depends entirely on the operating system. And here, please pay attention to my words. I am saying the operating system, not the kernel. How an installed application is graphically shown to the user depends mainly on the desktop environment, the file manager, and other user space services. And, as we learned in a previous episode, those are user programs. So the kernel is not the thing deciding whether something should appear as a normal folder, an app icon, or some other kind of graphical object. The kernel provides access to the file system. The graphical environment decides how to present that file system to the user. So the question we need to answer before continuing is this. Is the operating system aware of application bundles? The answer, like almost everything we cover here, is very interesting. Let's start with macOS. macOS is indeed designed to recognize application bundles, but if we, as developers, want our bundles to be recognized correctly, we need to follow certain conventions. The first one is the .app extension. Finder, as a user space program, constantly asks the kernel for the contents of whatever directory we are exploring. The file system still contains the same things we see from the shell, but Finder does not have to display those things in the exact same way. The .app extension in macOS tells Finder that a directory should be treated as an application bundle. So instead of showing it as a normal folder, Finder shows it as a standalone application using an icon stored somewhere inside the bundle. If the user clicks the bundle, Finder does not show its contents. Instead, it runs the executable contained somewhere inside the bundle. If you do not believe me, try this. Go anywhere in your file system. I will do it on the desktop. Create a folder whose name ends in .app. macOS will ask if you are sure, and you can press yes. Immediately, you will notice that instead of showing a regular folder, macOS shows an application icon. Since there is nothing useful inside it yet, it will use a default icon. If you double-click it, you will see a message like this. That's because there's nothing inside. Now, open the Applications folder in Finder. Pick any application, right-click it, and press Show Package Contents. This tells Finder to show the contents of the bundle instead of launching it. Now copy the contents folder from that application and paste it into the fake .app folder you just created. If you wait a bit, macOS will eventually start showing that folder as an application, and if you double-click it, the app will actually launch, because now the bundle contains the internal structure macOS expects. A typical macOS application bundle has a specific internal layout. Inside the bundle, there is usually a contents folder. Inside that folder, there are several other directories and files. The macOS folder contains the actual executable files the app needs. The Resources folder contains assets like icons, images, localizations, and other files used by the app. The Frameworks folder contains libraries and frameworks the application depends on. Some apps may also include folders for plugins, helpers, or other components. But the most important file inside the bundle is this one, info.plist. This file tells macOS things like what the app is called, where the actual executable is located, which icon finder should show, what file types the app can open, what permissions or capabilities it needs, and what version it is. In other words, in macOS, the info.plist file inside a bundle tells the operating system many of the things it needs to know about the application. Whenever Finder finds a directory ending in .app, it knows it should treat that directory as an application bundle and look inside it to determine how to display and launch the app. So when we install a macOS app by dragging it into the Applications folder, we are not just dragging an icon. We are dragging an entire bundle, a directory full of resources that both the app and the operating system need in order to make that app look and work as expected in the desktop environment. And this is a very important point. This abstraction is only possible because Finder and the desktop are not the kernel. They are user space programs. They are still part of the operating system experience, but their job is to abstract a lot of underlying complexity away from the user. A Unix shell does not automatically understand that a .app directory is an application bundle. If we want to open a .app application from the Mac OS terminal, we need to use the open command and pass the bundle as an argument. That command does not directly execute the .app directory. Instead, it instructs the shell to open the bundle the same way Finder would. By reaching the info.plist file inside the bundle, determine the actual executable file and tell the kernel to run that instead. I guess that answers the main question of this video, but naturally, you might now be thinking, what about Windows? Everybody knows that installing apps on Windows usually requires running an installer. Windows also has dedicated directories where application files are usually stored. Program files for most modern applications, and program files x86 for older 32-bit applications running on 64-bit versions of Windows. So why is it not as simple as dragging a bundle into an applications folder? If we open this directory from both the terminal and Windows Explorer, we can see something important. Both show these applications as folders. So the first thing we can conclude is that Windows is not designed to recognize application bundles in the same way macOS does. Windows does not look at an application folder and say, "This is a bundle, so I will display it as a single application icon." Before explaining why installers are so common on Windows, let's explore one of these application folders. We will use Firefox as an example. As we explained before, an application is not usually shipped as just one executable file. It also needs dynamic libraries, configuration files, assets, plugins, and other resources, which we can clearly see right here. Now, if you are the kind of person who pays attention to every detail, you might have noticed something interesting here. Did you notice it? If not, let me help you by listing the contents of this folder in the terminal. Still nothing? This file right here is an executable file, but Windows Explorer is showing a dedicated icon for it. And this is one of the key differences. In macOS, Finder shows an icon for the entire .app bundle based on the bundle's internal structure and the information stored in info.plist. In Windows, the executable file itself can contain resources such as icons, version information, and other metadata. So when Explorer finds an .exe file, it can display the icon embedded directly inside that executable. And you can test this yourself. Just copy the file somewhere else. No matter how many copies you create or where you paste them, Windows will keep showing the same icon because that icon travels with the executable. But the executable does not contain everything Windows needs to know about the program. For example, what kinds of files can this application open? Should it be the default app for certain file types? How should it appear in the Start menu? Or how should it be uninstalled? A lot of the system-wide application configuration in Windows is stored in something known as the Windows Registry, which is basically a centralized database used by the operating system and by applications. This database helps Windows keep track of installed applications, uninstall information, file associations, default programs, context menu entries, application paths, and many other pieces of system integration. And that has a very important implication. Windows does not automatically scan a folder and infer everything it needs to know from a single file inside it, the way macOS does with info.plist. Instead, Windows expects all that kind of information to be in the registry. This means that, Before Windows can fully recognize an application as an installed program, something has to update the system with that new information. That is one of the main reasons Windows applications usually use installers. The installer creates a new folder for the application in Program Files and copies the bundle files there, but it also integrates the application with the rest of the system, updating the registry and creating the shortcuts to show the app in the desktop. So, if you are running Windows, the next time you install an app, you probably will not miss that updating component registration step during the installation process. And this is what makes the installation process different between macOS and Windows. On Windows, the installer is needed not just to place the application somewhere on disk, but to connect that application to the rest of the operating system. For Linux users, I have bad news. That phrase you guys love plays a very annoying role in this situation. If Linux is only a kernel, then different Linux distributions are created by combining that kernel with a lot of different user space programs, all chosen according to different goals and philosophies. Technically speaking, they share the same kernel, but they are different operating systems. And remember, kernels do not really care about installed applications. That concept belongs mostly to the desktop environment, the file manager, and other user space components. So, if different distros are built around different philosophies, with different desktop environments, how can we expect them to be compatible in this area? Surprisingly, they are. Mostly. Most Linux desktop environments follow a shared convention called the XDG Desktop Entry Specification, originally from freedesktop.org, a collaborative project that creates open specifications and software to improve interoperability between Linux desktop environments. However, the real nightmare on Linux is not the desktop entry, but the distribution method. There are different package managers, different package formats, and a million different ways to package an application. Every distro maintainer seems to have their own preferred solution, and explaining all of that here would make this video 20 minutes longer. So we will talk about that in a future episode. For now, I just want to share my opinion on which method I prefer between Windows and macOS. And you might be surprised to know that I actually like the Windows approach the most. To be clear, I do not dislike the macOS approach. As I said before, once you understand what is actually happening when you drag that icon into the Applications folder, it kind of makes sense. But that is exactly where the first problem appears, the Applications folder. On Windows, the installer usually shows you where the application files are going to be written, and if you do not like that location, you are often free to pick another one. This is possible because the installer can simply submit to the registry whatever location you pick, and Windows will still know where the application is. On macOS, that is not usually how things work. You can't really pick another location. As far as I know, macOS expect application bundles only on these directories. Unfortunately, I cannot give you a definitive answer as to why macOS uses only these specific locations. Ironically, even though the macOS kernel is open source, macOS as a complete operating system is not. But my best guess is that this is mainly done for discoverability. To avoid problems like constantly scanning the entire disk for application bundles and showing them in Launchpad, macOS expects applications to live in a few specific places. That way, the system only needs to scan those known directories instead of searching everywhere. Anyway, macOS users often argue that installing applications is intuitive and simple. Just drag and drop, and you are good to go. And for many applications, that is true. But then we have another problem. Some apps are not distributed alone. They are distributed as part of a suite, like Microsoft Office or Adobe Apps. In those cases, or simply when the app needs to download and install system-wide dynamic libraries or other shared components that are meant to live outside the bundle, you usually end up running an installer anyway. Otherwise, you would have to manually drag multiple bundles and support files into different places, which would be ridiculous. So yeah, I guess that is clear proof that sometimes installers and uninstallers are just unavoidable. In fact, you might be surprised to hear that the Linux approach to installing applications is closer to the Windows approach than to the macOS approach. So stay tuned, because you will not want to miss that in the next episode. Don't forget to check Let's Get Rusty, linked in the pinned comment below. And if you liked this video or learned something new, please hit the like button. It's free, and that would help me a lot. See you in the next one.